Hello, and a massive welcome to all you incoming foundation students at University Malaysia Sabah. You are officially stepping into the brain of Borneo, and honestly, we couldn't be more excited to have you here. I'm going to be your guide today through this comprehensive explainer for the Asasi UMS SESI 2026-2027 chemistry course briefing. We've basically taken all your critical course documents, the syllabi, the structural guidelines, the whole shebang, and distilled them down into this easy-to-follow visual roadmap. So by the end of our time together, you're going to know exactly what's expected of you, how to navigate your theory and practical modules, and precisely what it takes to crush it in this rigorous academic environment. Ready? Let's get into it!
Okay, let's dive into the agenda for today. First up, we'll welcome you to Borneo's brain. Second, we'll break down the two chemistry paths. Third, we're mapping the syllabi terrain. Fourth, we'll cover laboratory protocols and assessments. Fifth, we'll look at your digital campus stack. And finally, number 6, how to truly excel here.
Section 1. Welcome to Borneo's brain. Meet your academic guides.
So, welcome to your new physical campus home, Pusat Persediaan Science Dam Technology, better known as PPST. This facility is the literal heart of your foundation studies. And look, I want you to remember that within these walls, you are never, ever alone on your academic journey. Let's actually meet the incredible minds who are going to be working right alongside you.
Handling your intense lectures, the tutorials, and generally overseeing your lab sessions is this remarkably diverse and dedicated academic team. You are going to be learning directly from Dr. Muhammad Razali Shamsuddin, Dr. Mohed Azral Abdul Razak, Dr. Eddie Mohad Fraid Mohad Yasli, Dr. Hazlinda Mohad Sadek, and Dr. Nas Shahida Azri. And supporting this core curriculum, we also have Ms. Nur Hazwani Dahorn, Madam Megawati Mohad Yunus, and Dr. Ayo Fika Nasrullah. This dynamic group, they are fully committed to giving you the absolute best baseline in chemical sciences possible.
Now, because chemistry is fundamentally an experimental science, your practical labs are just as crucial as your lectures. You'll be closely supervised by our brilliant lab demonstrators and tutors, including Madam Noreza, Ms. Atika, Ms. Arifa, Ms. Manjia, Ms. Fachen Junaida, Ms. Nazira, Ms. Asma, and Ms. Nurul and Jiha. And of course, the real backbone of our facilities, the ones making sure every chemical and apparatus is perfectly prepped, are our incredible lab officers, Mr. Mohammed Nazman bin Mid Nasser and Mr. Mohammed Atif Nakiuddin. A quick pro tip: always treat these facilitators with the utmost respect. They are literally the guardians of your safety and your success in the lab.
Section 2. The two chemistry paths, Science Foundation versus Agroscience Foundation.
All right, let's look at the timeline constraints for these dual tracks. On the left side, we have the Science Foundation path, which uses the SK codes. In Semester 1, you're going to tackle SK0014. That's a rigorous 4-credit theory module paired right alongside SK0011, which is your 1-credit practical lab. Semester 2 then advances you into SK0024 for theory and SK0021 for the lab. Now on the right, the Agroscience path mirrors this exact physical constraint, but uses AK codes. So Semester 1 is AK0014 theory, paired with the AK0011 practical, followed up by AK0024 and AK0021 in Semester 2. So regardless of your track, you are looking at a demanding 4-credit theory and 1-credit practical split across both semesters.
Section 3. Mapping the syllabi terrain. Progressing from foundational mechanics to advanced applications.
Now, what's really interesting about this next part is how it all builds together. We are going to treat this syllabus like an exciting roadmap, explicitly detailing the 14 major lecture topics for Semester 1 Physical and Inorganic Chemistry. That's SK0014. It all kicks off with Topic 1, Atoms, Molecules, and Stoichiometry Part 1. That flows right into Topic 2, Atoms, Molecules, and Stoichiometry Part 2. Next, Topic 3 tackles the state of matter and structure of solids. In Topic 4, things heat up with reaction kinetics, right before we stabilize in Topic 5 with chemical equilibria.
And the theoretical foundation just continuously stacks from there. Topic 6 shifts us right into ionic equilibria, immediately followed by Topic 7, solubility equilibria. From there, Topic 8 introduces the fascinating world of electrochemistry. Then, Topic 9 measures energy transfers in thermochemistry, which perfectly sets the stage for Topic 10, a deep dive introduction to inorganic chemistry.
Concluding your Semester 1 deep dive, we have Topic 11, exploring electron configuration and atomic orbital. Topic 12 analyzes the periodic table, specifically focusing on periodicity and transition elements. Topic 13 binds it all together, pun intended, with chemical bonding. And that brings us to the final hurdle, Topic 14, Lewis structure, VS EPR, and hybrid orbitals.
Moving into Semester 2 with modules SK0024, your precision gets tested right away. Let's watch the first 8 topics cascade in. 1. Introduction to Analytical Chemistry and Error in Chemical Analysis. 2. Gravimetric Analysis and Volumetric Analysis. 3. Principles of Neutralization Titrations. 4. Analytical Instrumentations. Now at 5, we unlock the Introduction to Organic Chemistry, pushing straight into hydrocarbon chains for 6, hydrocarbon I, alkane, 7, hydrocarbon 2, alkene, and 8, hydrocarbon 3, alkyne. And for the second half of Semester 2, you are diving into the deep end of functional groups. 9 is arene, 10, haloalkanes, 11 is the hydroxy compound, and 12, the carbonyl compound. We're getting into some really complex molecular territory here, capping off with 13 carboxylic acids and derivatives, 14 nitrogen compounds, and finishing strong at 15 with polymer. Moving right along to Section 3, the Agri-Science Foundation track. As you can see from the vibrant emerald green theme, modules AK0014 and AK0024 are tailored specifically for natural, practical field applications. Semester 1 starts with AK0014 Fundamental Chemistry I. Here are your first 7 pillars. 1. Introduction of Chemistry. 2. The structure of atom. 3. State of matter. 4. The chemical formula and equation. 5. Acid and bases. 6. Salt. And 7. Redox reaction. Rolling right into the rest of the semester, Item 8 is electrochemistry. 9 is thermochemistry. Then we go microscopic with 10 electronic configuration and 11 periodic table of elements. 12 covers chemical bonding, 13 is Lewis structure, and we wrap it up at 14 with manufactured substances in industries. That last one really connects your theory straight to real-world industrial agriculture. Semester 2 introduces AK0024, Fundamental Chemistry 2. Watch these checklist items drop in. 1. Introduction to Analytical Chemistry. 2. Gravimetric Analysis. 3. Volumetric Analysis. 4 is your Introduction to Organic Chemistry, followed by a rapid mastery of 5 hydrocarbon, ine alkane, 6 hydrocarbon, ine alkene, and 7 hydrocarbon, ine alkyne. Wrapping up the agroscience theory, we've got Item 8, haloalkanes, 9, hydroxy compound, 10, carbonyl compound, 11 is carboxylic acids, 12 is ester, and 13 is polymer. It all culminates perfectly at 14 with agrochemistry, literally bridging everything you've learned directly to the soil and the ecosystem.
So how are you actually graded? Well, your 4-credit module isn't just about endless memorization, it's dynamically evaluated. Yes, a massive 50% comes from your final exam. But listen to this. A full 30% is dedicated entirely to your group problem-based learning, or PBL. That requires real teamwork and presentations. The final 20% is split perfectly down the middle, 10% for your assignments and 10% for sharp, targeted quizzes.
Section 4, Laboratory Practical Modules, because, let's be real, theory is absolutely nothing without practice. This is where you transform from a student reading a book into an active, hands-on scientist. Now, to survive the lab floor, you're going to need these official laboratory manuals for your specific track. They are your ultimate survival guides. They contain every single rubric, regulation, and exact procedure you need to execute. Seriously, get your copy early. For the science track Semester 1, that's SK0011, you'll be conquering 7 critical experiments. Let's check the board. 1. Basic technologies of handling chemicals in laboratory apparatus. 2. Determination of the formula unit of a compound. 3. Factors affecting reaction rates. 4. Acids and bases. 5, and this is a really fun one, electron configuration, the chemistry of fireworks. 6. Investigating the properties of ionic and covalent compounds. And 7. Lewis structure and molecular geometry. In Semester 2, SK0001 puts your analytical rigor to the test with 6 labs. 1. The separation of the component of a mixture. 2. Bleach analysis. 3. Spectrophotometric analysis. 4. Reaction of hydrocarbons. 5. Identification of unknown organic compound. And 6. Investigation of alcohols and carboxylic acids. Agroscience students, you face an equally robust practical path for Semester 1 with AK0011. 6 key sessions here. 1. Basic technologies of handling chemicals and laboratory apparatus. 2. Periodic table, the chemistry of fireworks. 3. pH measurement and its applications. 4. Acids and bases. 5. Lewis structure and molecular geometry. And 6. Chemical bonding, the properties of ionic and covalent compounds. Your agri-science lab sequence concludes in semester 2 with AK002. You'll execute 6 practicals. 1. The separation of the component of a mixture. 2. Bleach analysis. 3. Reaction of hydrocarbons. 4. Investigation of alcohols and carbonyl compounds. 5. Zooming in on the investigation of carbonyl compounds, aldehydes and ketones. And 6. Carboxylic acids and its derivative.
Because your practical module carries exactly 1 credit hour, grading here is an exercise in extreme precision. A staggering 80% of this grade relies on your group lab report. You are being evaluated on your ability to conduct experiments and formalize the data perfectly. Another 15% comes from a rigorous 3-hour lab test, focusing on technique and teamwork, while the final 5% is allocated to lab management and your individual jotter book.
Now, I really cannot stress these protocols enough. These are zero compromise rules. If you violate them, you do not enter the lab, period. You must wear a standard white lab coat, fully buttoned up. Closed footwear is absolutely mandatory. No sandals, guys. Hair must be tied back. Safety goggles, face masks, and gloves, totally non-negotiable. Inside the lab, you have to strictly differentiate your disposal bins. Chemical waste goes in highly specific containers, completely separate from broken glass. Furthermore, you have to prepare your jotter book before you even step foot through the door, mapping out your procedural flowcharts. And finally, when you submit that massive 80% lab report, you must use the exact standardized UMS chemistry report template. No exceptions.
Section 5. Your digital campus stack. Mastering blended learning.
Let's move over to the digital side of things and see how this builds your daily workflow. UMS operates on a highly effective blended learning model, and your required daily digital footprint looks a little something like this. First, the ITEL portal. This is your main hub for all lecture notes, rubrics, and pre- and post-lecture activities. Second, you absolutely must join the official Telegram broadcast channels immediately. This is how the department officially communicates vital updates. Third is the Smart Hadir OBE system. Think of this as your digital attendance beacon that proves you are actively showing up. And finally, your day-to-day dynamic communications and live virtual classes are going to happen across Zoom, Google Meet, and your dedicated WhatsApp groups.
You need to log into itl.ums.edu.my securely using your standard UMS student credentials. The very first thing you've got to do is locate and enroll yourself into your correct SK or AK chemistry modules immediately. Seriously, get really comfortable with this dashboard. Completing your flipped classroom tasks, forum discussions, and quizzes ahead of time is absolutely critical to maintaining your grade here.
Section 6. How to excel here. The mindset for success.
So, what's the secret? The recipe for success here is simple, but it demands discipline. It starts with, well, simply going to class. Once you're there, you actively take notes and listen precisely to instructions. But the real magic, that happens outside the classroom. You must dedicate time to actually study, complete your tutorial sheets, and review your material before you ever walk through our doors. Consider this your ultimate Thrive checklist. Actively avoid procrastination and keep a sharp track of your own progress. And hey, don't try to do this alone. Build strong, supportive friendships with your peers. Most importantly, do not be intimidated by your lecturers and tutors. We are actually pretty approachable. Open up active lines of communication with us. We are literally here to support your success. And above all else, maintain a healthy, grounding balance with your family and your faith.
I'm going to leave you with this final provocative thought. Whenever the semester gets tough, and trust me, it will, take a step back and ask yourself, what is your big why? Why did you choose this path of higher education? Let your genuine passion for discovery, for science, and for your own future drive you forward every single day. Thank you so much for joining me on this explainer. Welcome to Asasi UMS. Now go out there and unleash your potential.